Hey everyone, I hope you had a nice weekend, that you enjoyed your weekend. Here we had a weekend with a little bit of rain in Vermont, but that's nice because it was really hot. Oh, it's my cat. So the purpose of today's video is actually to provide you with the tools to accurately display and analyze the water and soil lead concentration from your chosen sampling site to answer your hypothesis. So what we want, the goal of displaying the data, is to actually be able to extract and convey meaningful information on a selected number of figures and captions with an associated interpretive paragraph. And that's what is your assignment for today. We want you to add a page to your Google site that will report the data you collected and interpret the findings, including at least one map with a caption, one graph with a caption as well, and a paragraph that describes the data. You sampled 5 samples. You have 4 samples to test your hypothesis and 1 sample that is combined sample for your entire property. And that's what we're gonna start with to display the data. I also want to mention that the water samples, hopefully, and we'll get the result very soon. Before this video is made, I don't have the result, but hopefully you all have drinking water that is below the detection limit of 2 to 3 ppb of the instrument. And this is great if it's the case, and that means that it's going to be hard to display the results in any specific way. So what I suggest is that in your interpretative paragraph, you actually mention the result, you report the results in a sentence. The interpretation in that case will pretty much be the same if you are below detection limit, but you have to mention that you did 2 flushes, okay? That means that you have to interpret and explain the data according to these 2 flushes, meaning why did we do 2 flushes, and what the data means for flush 1, flush 2, and in comparison with each other. So remember, the different flush testing was designed to test different parts of the water system. Now the 5 points combined property sample, what we did there is that we sampled this to compare the lead concentration across geographic locations and provide with a simple number that can assess the level of contamination for a given property across a geographic area, may it Burlington or Jackson or the entire US. So we have one number only, and to convey important information there, I suggest that you build a figure that will allow a quick assessment of the property lead concentration in the context of the EPA standards for lead in soil. And I invite you to actually visit the website, which address is given on this slide. So these standards for lead in soils are of 2 types. There is one that is for bare soil in play area, and that is 400 ppm, meaning that if a soil has more than 400 ppm lead and that is a play area, this will need remediation or decontamination. And the second value is 1200 ppm in non-play area, so in areas where there would not be kid playing. So I would suggest you make a figure that displays that, shows that in this context. Here is an example of such a figure, but please feel free to be creative. This figure here I built using PowerPoint and playing around with some display options on PowerPoint. Now the bulk of the data analysis is on the 4 samples that you sampled for testing your hypothesis. Your hypothesis testing consisted for all of you to test lead concentration as a function of a variable. In a sense, as lead concentration is equal to F of your variable, which is a simple equation and can be graphed. So each of you simply need to determine what your variable is and graph that accordingly. In the case of the example that I use, or the hypothesis that I use to sample my house, the variable is building construction date, or in other words, building age. So once you have determined your variable, you will build a data set into a usable one. And This we will do using Excel. So to build our dataset, we will use Excel, or you can use any other type of spreadsheet software. Excel is the most common, and it's the one that most of you are going to be using. What we need in order to build our dataset is to have a certain amount of column information and rows for the number of samples. Hopefully all these columns should be the same across datasets so that if we ever need to do it, we're going to actually combine this dataset. So the columns that we need are in the number of about 7 columns, 7 different information. And we're going to start with a column with the sample name. For later, because we will need to do that, and it's always interesting to have this information, we will also record columns for latitude and longitude. Of course, one column for lead concentration, one for measurement error, and one column that will depend on your testable hypothesis, which is 1 or 2 columns for variables. So these variables could be age of the structure, they could be distance to a structure, they could be depths depending on what you've sampled, it could be whether or not your samples are in low lying elevation or high lying elevation. I will build it for my case, and in my case there will be 2 columns, one for the construction time and one for the age of the structure. And finally, I think it's always important to have a column that allows you to record any specifics on the sample. So I'm going to have a column called comments. So those are all our columns for the dataset. Yours may be a bit different, in particular regarding these variables like construction date or age of structures for me. But globally, we're going to have this type of columns. Now we're going to populate this diagram. We will not populate latitude and longitude yet. I will show you that later in the video. But we're going to start populating these. So sample names are going to be the sample name that you have had recorded during your sampling, and the lead concentration, lead error will be provided when we send you the results. And then your variable, you should know what they are. So I'm going to populate this one. I will leave the latitude and longitude blank for now, and then the value of lead that I have measured from the XRF, and the error the following. Now the construction date for these buildings is something that I have had from other dataset, and the age of the structure will therefore be 2020 minus the construction date. Now in comments, I will write some comments that I think are pertinent to my dataset. So this is the initial dataset. We will need to populate latitude and longitude if we want to provide with a map. But before we do that, we're just gonna generate a diagram of our data. What I think is the most interesting in my hypothesis is to test whether the age of the building is actually has an effect, has an influence on the concentration in lead in the soil. So I'm going to plot this as a graph that will represent the concentration of lead as a function of the age of the house. So if I write it simply, there would be concentration of lead is a function of the age. Y equals Fx. So I will plot the age as the x-axis and the lead as the y-axis. So if I do that, I take my structure, age, and my lead concentration, and I will insert a graph to represent this. Now, of course, it always takes the first column you select as x and the second as y. So I'm gonna revert that, go to select data, edit my data set. My series name doesn't matter so much here. I could call it lead Nico, and I will change my x value to actually the age of the structure and my y value to the lead concentration. Now I want to make my graph pretty. I want my graph to actually display some more information to show some interesting data. And so I'm going to make my graph pretty. I will need some important information such as the axis title. So I'm going to just add title to my axis here in add chart element. This is in design. My horizontal axis is the age of the building. The y-axis is the topsoil lead concentration. I will make sure that everything is visible, so I will actually increase the size of my axis labels. I will also want to make sure that my points make sense and are visible, so I'm going to change that by double clicking there and change the marker type. So other information that would be very important, very interesting for me, is related to the error on the measurement. So I have this column that is error, so I can select my data set and now add error bars. And these error bars are given by the data, so I'm going to go to more error bar options, select both, okay, and specify the value by selecting custom. And here we go, we have our error bars. What we see is that actually our error bar is behind the point. So we have a very small error that is not visible on the graph. But it's important to look at it because maybe sometimes this error will be visible. One important information, one that I think is gonna really help us interpret this data set, is to know when was lead paint actually banned in the US. And so maybe it's gonna inform me on some kind of difference in my data set between points. And lead paint was banned in 1978, so that's about 42 years ago. So any building that would be younger than 42 should have limited lead. So I'm going to add that data onto my chart. So I'm going to insert shape, and it's going to be a line at 42. Trick, if you want to make your line straight, it shifts at the same time as you draw the line. And then provide information about what that line represents. So that line here represents, on one hand, buildings that were constructed after the lead paint ban. All right, and the last information I may want to display is specifics about the samples related to comments. And here I think that I have a graph that actually makes sense, that is displaying quite some interesting information, actually interpretable, as we see that indeed it seems that there is a correlation between the age of the building and the total lead, the topsoil lead concentration. That is a little bit different if you have vinyl cover on top of a house, which actually would protect the lead paint that is underneath from flaking more and limit the release of lead paint into the environment, but apparently not completely and only to a specific extent. So that's a graph that would make sense. Of course, what we're missing here in this graph, and it's going to be very important, is caption to the graph. So you need to explain to whichever reader of your website what this graph represents. It's not enough to have only the axis or the information that are on the graph, but it's important to actually have a caption that explains, maybe it's the topsoil lead concentration has a function of the age of building. A vertical line in the graph showing the date of the lead paint ban in the US. Something like that. You can even have some little interpretation in your caption, but we are asking you in your assignment to have additional paragraphs to explain these graphs. So that would be where you do it. that's it for this graph. Now we're going to move on to the map. So save that file. Now don't necessarily close that file right away, because what we want for the next step is to have the same data set but in a format that is comma separated value. So what I would recommend you do is save again that file, save as, but as CSV, and so that will be this here. So one of the intermediate steps is to record or extract the information about longitude and latitude on your samples. So for that you can go simply on Google Map and zoom onto the area where you've sampled. In my case, this is La Fontaine Street, which is that street, and this is this property here. Now notice that you can actually add some points to your map wherever you are clicking. Okay, and that these points record some values of latitude and longitude. So you can add location by just clicking on the map. Here is the first point that I got, and you will have this information that is noted at the bottom of the page there. Your data will be potentially already in decimal degrees. If it's not the case, just click on the decimal degrees and it will provide you with both the degree minutes seconds, which we don't want, and the decimal degrees underneath. So record that in your Excel file or on a piece of paper, and then on your Excel file. And we are talking about the CSV file there, the one we have populated before. So I'm gonna just record this data. And here we are, we have our coordinates for all 4 points, which now we will be able to map. Don't forget to save and make sure that it's still a CSV file. The final step of displaying the data for interpretation is to create a map. Because we are going remote, etc., and you don't all have the computing power, we're going to use an online tool which is called ArcGIS Online. The first step is to actually go on ArcGIS Online. Type ArcGIS on Google and you will find it right away, and then create an account if you don't have one already. You may have from other classes, from things you've done before. So you create an account. I already have an account, so I'm just gonna sign up, but the creation of the account page is here. This is how you will go if you create an account, and you're just gonna create a public account there. And the way it goes is that you just have to enter your name, email, and click on these 2 boxes, and you'll be able to create an account. You'll receive an email to activate your account, and then you'll be able to sign in, just like I'm doing right now, where, well, I'll just be able to sign up into my account. So now what we just want to do is make a map. Click on make a map. And it will by default center on the United States. We already have our data set, and you already have entered latitude, longitude, so we have formatted our data set as a CSV file so that we can actually add our data set as a layer on our map. And so we're just gonna add a layer from a file. It tells you that your file should be the shape file, which is a typical GIS file, CSV or text file, a JPSX file, which is a GPS file, or a GeoJSON, which is some kind of other type of format. And so you just browse and you add your file, and then you import the layer. It will automatically zoom on the area where the points were. You can change the base map to display something that may be make more sense, and maybe we'll put an imagery or an hybrid imagery which actually adds the roads there. I will just select the hybrid imagery here, and you want to select the attribute that you want to show. In our case, of course, it's always going to be the concentration of lead. It opens a bunch of options on how to display the data. But before that, I want to make sure that my points are well located. You can select a point and say edit. It will allow you to drag the point to the actual location. We can save the map for now. So we can go back to our layer, see that we actually have two content in our layer. We have the data that I added in CSV file and the imagery that is behind. And now we can select how to display that layer. And that's here, the change style icon. So again, I want to select LED as my display option. And here, by default, what it did is select size as a representation of the lead concentration. And that's what you have here as a selection possibility. You could show the size, bigger points, smaller points. You could show a difference in color, or you could do a heat map, so represent the spread of the data over a larger area, which in our case with only 4 points is not going to work very well, although it would be very nice. Or we can select individual points to display individually, or add some kind of options to display the point. I think what would make sense is to actually have the color as a function of the lead concentration. And so I'm going to select that, count and amounts, and select the options so that I can show the different concentration as a function of color. I will change the symbol to display some kind of scale that makes sense, maybe this one. There's not a lot of options when we are online. Of course, GIS files, softwares will give you a lot more options. Okay, and I will want to make sure that my data is kind of nicely spread. If you look at the legend that we have here at the bottom, these data points don't make much sense. At least this division doesn't make more sense. Maybe I want to make it match something that I know, like the EPA limits. And so I'm going to just classify my data using equal interval, which means that, or intervals, which means that actually the data will be spread over always the same amount of lead change. And then I will run my classes by hundreds and change the number here. Always have to redo that after, so that I have here 400 as my limit. So anything that is below 400 is going to be this light yellow here. Anything that is between 400 and 1200 is going to be these two colors, and then the rest is going to be in the red and dark orange color. So that kind of would represent the data. But maybe I can even go further. Oh, actually, I'll use that one. It's better. When you do equal interval manual breaks, it actually gives you more options. I invert the color ramp, and here we go. Anything that is blue is okay by EPA, then anything that is in tones of orange or red will not be nice. So we have our symbols. Unfortunately, we cannot really change the size of the symbols. I would like them to be bigger, but it doesn't show very well there. And then don't forget to save regularly. And now we can actually generate a map with legend by hitting print. And here we go. So now I have a map that shows my data set. And I can just either save the image, but it will only save the image, so I'd rather do a print screen of just that image so that I can display my map on my website or on any other kind of things. So for example on a PowerPoint. And here you go, you have your map. Hope that helps and that you get a little bit more on how to use GIS in this assignment. Hope you enjoyed the video, and I'll see you tomorrow for a video lecture on remediation. What do we do when there is high concentration?